Hello there. Now is another time for basic science lesson. Now we'll be having the concluding part of our lesson, Kinetic Theory of Matter. And in this particular lesson, we'll be looking at kinetic theory of matter and change of state. We're looking at kinetic theory of matter and change of state. Now moving along, our objective is to ensure that learners are able to describe the effects of heat on the kinetic energy of a particle. Use the kinetic theory to describe the process of condensation, melting, boiling, and freezing. And also, learners should be able to distinguish between boiling and evaporation. Now, moving along, we'll be looking at the effect of temperature on kinetic energy of particles. So, the subheading is temperature and kinetic energy of particles. Now, one of the kinetic molecular theory postulates states that the temperature of a substance is related to the average kinetic energy of the particles of that substance. What it means is that there is a direct relationship between temperature and kinetic energy of a substance. In other words, if we increase the kinetic energy of a particle, the temperature will also increase. Now, it says that because kinetic energy is the energy of a substance has because of its molecules being in motion. As a substance absorbs heat, in other words, as the temperature increases, its molecules move faster, thereby increasing the substance's kinetic energy. In other words, if you increase the temperature of a certain particle, it will move faster, thereby increasing its kinetic energy. Now, you can see here, you have gas particles, kinetic energy, and temperature. It says that kinetic energy is proportional to temperature. That means as temperature increases, the kinetic energy of a particle will increase. The particle will move faster. As the temperature decreases, the kinetic energy of that particle decreases. In other words, it moves slowly. Now, moving ahead, we'll be looking at kinetic theory, and we'll be using it to explain the change of state of matter. Now, according to the kinetic molecular theory, changes of the states of matter occur when energy in form of heat is added or removed from a substance. In other words, in kinetic molecular theory, change of state can only occur by the addition and removal of heat energy. Now, the addition of energy, which is heat, makes particles move more, pushing them apart and weakening the bonds between the particles. Now, removing energy, that is heat, makes particle movement slow down, reforming bond. So this is the summary of how the kinetic theory, and change of state works. Now, as you can see right here, as solid is being changed to liquid and liquid change to gas, energy in form of heat is what will make that happen. Is what will make the process of changing from solid to liquid and from liquid to gas happen. But if gases will change back to liquid and liquid will in turn change back to solid, you need to remove energy. In other words, you need to remove heat for that to happen. Now, moving along, we'll be talking about change of solid to liquid through the process called what? Melting. Now, a solid consists of low kinetic energy vibrating particles locked into position by intermolecular attractive forces. When heat is applied, energy is absorbed and the particles start vibrating more vigorously. Finally, the vibrations become energetic enough to overcome the attractive forces, and the particles start sliding out of their positions to flow about. Now, the solid will melt and turn into what? Liquid. So, as you can see right here, for melting to occur, melting is the process whereby a solid changes to liquid by heating. Now, as you apply heat to this solid right here, which is ice, now the molecules begin to vibrate till they are able to overcome the intermolecular forces of attraction between the particles. And once that happens, they break free, causing the particles to flow on one another, which will make the particles melt and turn to liquid state. Now we'll be looking at the change of liquid to solid, and that process is called freezing. Now, in freezing, the particles still have energy enough to slide about within the volume of the liquid, but further cooling lowers this energy further. Finally, the mutual attractive forces overcome the low kinetic energies of the particles and lock them into fixed positions where they continue to vibrate as the liquid freezes to solid. Now this is the process right here. Freezing is the change of liquid to solid by cooling, in other words by removing heat energy. So as you remove heat energy from this liquid right here, what will happen is that all the particles in liquid will begin to lose kinetic energy, and once they lose kinetic energy, the forces of attraction between them begins to increase, bringing all the particles together, which will turn them into solid eventually. So this is the process right here, freezing. Now next we'll be looking at change of liquid to gas through the process called boiling. Now on further application of heat to liquid, the particles move around more energetically within the volume of the liquid. Finally, they become energetic enough to start escaping from the surface of the liquid, overcoming the backward pull by their neighbors in the volume of the liquid. Now the process of boiling has begun, wherein the liquid converts towards gas as particles escape to move around independently without any restraint. Now this is the pictorial process right here. What happens is that as heat is being applied to liquid, the liquid will receive enough kinetic energy that will cause it to escape from being held down by the intermolecular force of attraction within the volume of this liquid right here. So once a particle gains enough kinetic energy, it will escape off the surface of the liquid and it will escape into the surrounding atmosphere, not being bound by any force. So now the liquid will turn towards vapor or gas. Now finally, we'll be looking at the last process that we'll be talking about in this video, which is condensation, which is the process by which gas changes back to liquid. Now when a gas is cooled, in other words heat is removed, progressively the free moving particles start losing kinetic energy and slow down. Now finally, the forces of attraction between the lower energy particles colliding with each other are strong enough to hold them together, and the gas begins to condense into liquid. Now look at the picture right here. Condensation is the change of gas to liquid by cooling. What happens is that as you remove the temperature, or reduce the temperature, or as you cool the vapor that you have right here in this container, what will happen is that the particles will begin to slow down, gradually losing kinetic energy, and the bonds between the particles will begin to reform, causing it to return to change state into liquid. And that's what happens. The vapor condenses into liquid state. Now finally, before we go, we'll be talking about the differences between boiling and evaporation. As you can see right here, boiling is a process in which a substance changes its state from the liquid state to the gaseous state, whereas evaporation is a process whereby the water changes into vapor without boiling or heat. Boiling is a quick process, evaporation is a slow process. In boiling, bubbles are formed, and in evaporation, no bubbles are formed. Boiling occurs throughout the liquid, whereas in evaporation, it only takes place on the surface of the liquid. In boiling, it occurs at a definite temperature, which is the boiling point, while evaporation occurs at all temperatures. Now, source of energy is needed, source of heat energy is needed, but in evaporation, energy is supplied by the surroundings. Now, this brings us to the end of this lesson on kinetic theory of matter and change of state. Now let's take a quick look at the summary. One of the kinetic theory postulates states that the temperature of a substance is related to the average kinetic energy of the particles of that substance. According to the kinetic molecular theory, changes of state of matter occurs when energy in form of heat is added or removed from a substance. The addition of heat energy makes particles move more, pushing them apart and weakening the bonds between them. Removing energy, that is heat, makes particle movement slow down, reforming the bonds. The processes in change of state of matter are melting, boiling, freezing, condensation. these processes require the addition or removal of heat. Now we've come to the end of the lesson, but before we go, I want you to pause this video and attempt to answer the question in this assessment to see how much of the lesson you have imbibed, and I'll see you again in the next lesson.